Hi guys, today we're going to be talking about how to find formal charge. So I have a couple different Lewis structures here, and we're going to look at each one of their individual atoms and try to determine their atom's formal charge. So first I have this Lewis structure of ClO4-, which has a chlorine atom. It has a top oxygen, a right oxygen, a bottom oxygen, and a left oxygen. Alright, so to find formal charge, our first step is going to be to find the valence electrons that the normal atom would have. So if we take a look here at our periodic table and we locate chlorine, which is in the 17th group, we can find valence electrons by starting in group 1, skipping the transition metals, starting in group 13, and counting our way over to our desired atom. So for chlorine, it would be 1, 2, 3, 4, 5, 6, 7. So going back over here, we can say that chlorine has 7 valence electrons. Our next step is going to be to find the electrons assigned to the atom in the Lewis structure. So looking at chlorine, we see that it has no individual atoms assigned to it, but it does have 1, 2, 3, 4 bonds. Each of these bonds represents 2 electrons. So that would give us a total of 8 electrons for chlorine, except each of these bonds is shared with one of these oxygens. Since they're shared electrons, we're only going to assign 1 electron from each bond towards chlorine. So that is going to give us a total of 4 electrons assigned to chlorine. Our third step is going to be to subtract the assigned electrons from the valence electrons. So that'll give us a total of +3, which is going to be chlorine's formal charge in this Lewis structure. Alright, so let's look at this top oxygen. Going over to our periodic table, we can locate oxygen as it is in the 16th group of the periodic table. And then counting our way over, 1, 2, 3, 4, 5, 6, we see that oxygen has 6 valence electrons. Now looking at our top oxygen, we see that it has 1, 2, 3, 4, 5, 6 individual electrons assigned to it, plus this one bond that it shares with chlorine, which we know we're going to split in half, so that's going to add 1 electron to our total, giving us a total of 7 assigned electrons. When we subtract that from valence electrons, we see that we have a formal charge of -1. Alright, looking at our right oxygen, we already know that oxygen has 6 valence electrons, and that doesn't change no matter what structure it's in. And then we can look again at our assigned electrons and see that it has 1, 2, 3, 4, 5, 6 assigned individual electrons, plus this one bond, which gives us another 7. Which gives us another formal charge of -1. If we continue to look at all the rest of the oxygens in the structure, we'll see that they have the similar structure as the first two, meaning that they've been assigned 6 individual electrons and they share a bond with chlorine, so all of them are going to have 6 valence electrons and 7 assigned to them, which gives them all a formal charge of -1. Alright, our final step when determining formal charge is going to be to make sure our formal charges add up to the charge of the structure. So looking at ClO4-, we see that it has a charge of -1. So we want all of our charges to add up to that -1. So we have +3, -1, -1, -1, -1, which turns out to be 3 minus 4, which does indeed equal -1, so our formal charges seem to be correct here. Alright, now let's look at the structure of NCO that we have here. And it also has a -1 charge. So first we have a nitrogen atom, then we have a carbon and an oxygen. Alright, so let's start with our nitrogen. Returning to our periodic table, we can locate nitrogen right next to oxygen in the 15th group. And then counting our way over, we see that it has 1, 2, 3, 4, 5 valence electrons. So then returning to our structure, we can say that it has 5 valence electrons. Now let's look at this N atom. It has 1, 2, 3, 4, 5, 6 individual electrons assigned to it, plus 1 from this bond it shares with carbon. So that'll give us a total of 7, which gives us a formal charge of -2. Now let's look at carbon. Returning to our periodic table, we can locate carbon right next to nitrogen. And so we see that we already counted over there and see that it has 4 valence electrons. Okay, so we have 4 valence electrons, and then we see that it has no individual electrons assigned to it, but it does have this bond it shares with nitrogen, plus this triple bond that it shares with oxygen. That gives carbon a total of 8 electrons from each of the bonds, but like I mentioned before, it shares those bonds, so we're only going to assign half of the electrons to it, and that's going to give us a total of 4. So we're going to subtract that 4 from 4 and see that carbon's formal charge is 0 in the structure. Finally, let's look at oxygen. Oxygen, we know, has 6 valence electrons. It shares this triple bond with carbon, and it has these 2 individual electrons assigned to it. The triple bond supplies 3 electrons plus the 2 individual electrons we have, which totals 5. Subtracting that 5 from our 6 valence electrons, we see that oxygen's formal charge is +1. Alright, finally we see that our total structure charge is -1. So adding all of our charges together, we see that we did indeed end up with -1 as our charge, so that works out as well. Finally, let's look at our COCl2 structure. So we have a carbon, an oxygen, a right chlorine, and a left chlorine. Alright, so from above we know that carbon has 4 valence electrons, and then looking at the structure we see that it has 2 single bonds with each chlorine and a double bond with the oxygen, which totals in 8 electrons from each bond. But as I mentioned before, you do only count half of those towards carbon since they do share, and that's going to give us a formal charge of 0. Next, looking at our oxygen, we know that it has 6 valence electrons, and in this structure it has 1, 2, 3, 4 individual electrons plus this double bond, which gives us a total of 6, meaning another formal charge of 0. From the very top up here, we counted that chlorine had 7 valence electrons. Now looking at right chlorine, we see that it has 1, 2, 3, 4, 5, 6 valence electrons, plus 1 from its bond with carbon, which gives us a total of 7, and another formal charge of 0. Finally, looking at the left chlorine, we see that it also has 1, 2, 3, 4, 5, 6 individual electrons assigned to it, plus 1 from its bond with carbon, which gives us another formal charge of 0. This makes sense, as there's no brackets around the structure, which would represent that there would be a charge, so we can assume that the structure is neutral, and so all of our charges should add up to 0, which they do. So just remember, to find formal charge, first we find valence electrons. Second, we find the electrons assigned to each atom in the structure. Third, we subtract the assigned electrons from the valence electrons. And finally, we add all of our formal charges together to make sure that they add up to the charge of the total structure. Have a good day.